All right, everybody, welcome back. We are right at the top of the hour, so let's get started. My name is Krista Miller. I'm from Virginia Tech. I use she, her pronouns, and I'm the Associate Director of Services for Students with Disabilities. This afternoon, my description. I'm a white woman with shoulder-length brown hair, and I wear glasses, and I am joining you from my virtual background for the conference. And this afternoon, we're going to be hearing from Brad Held. The session is being recorded and will be shared after the conference. If this is your first session with us today, please know that the session's being professionally captioned and you can access that through the Zoom menu to turn it on or off. Please post all your Q&A questions to the Q&A feature. You have the option to post anonymously if you prefer. And if you prefer to ask questions out loud, please let us know in chat so that we can unmute you. If you have any issues with Zoom during our session today, please let us know in chat, or you can email tap@wfu.edu. All right, so our session is Tools Consideration for Accessible STEM Digital Content. Brad Held, the Digital Accessibility Office Lead of University of North Carolina at Chapel Hill, is joining us. And Brad serves as the head of digital accessibility at the University of North Carolina, Chapel Hill. He oversees the campus implementation of a stronger accessibility initiative at UNC and works to raise awareness on accessibility to key stakeholders across campus. Take it away, Brad.
Thank you, Krista. And thank you, everyone, for being with us here today as we round out the 2022 conference. And we're so happy that you were able to join us today. As was mentioned, the title of my presentation, there's also a link that I've placed into the slide deck, where it is tinyurl.com/NC-AHEAD-AC 2002-held. Of course, as we talked about earlier, we're also going to work on getting my session shared with you so that you can download the slides. There are a number of links at the end of the session that hopefully will be helpful for you. So just a little bit before we get started, this presentation is an overview presentation, and so this will not really go into any advanced techniques per se on how to do STEM, but really give you an overview. If you are interested in this, one of the resources in this slide deck is the North Carolina Community College Systems Virtual Lab Math Guide. And so I encourage you to go and look at that guide if you want more advanced and a very wonderful guide to be able to see how this all comes together. But that's really what I'm doing here today, to let you know where I sort of thought of this presentation. It came from a faculty member at a different institution. It wasn't at UNC that said, I know that I need to make it digital, but I don't know how it all works, and I think a lot of that with digital accessibility happens. People know that it's digital, it's maybe on your computer, but how does that make it so that that blind person can see it, or that person that only uses a keyboard, how can they access that content? And so there used to be a wonderful tool called the Math Support Finder, created by Benetech. It's no longer available, but I did show that with the individual, and it really just looked at the considerations that we're going to look at throughout this presentation to give you an overview of what to consider and what to think about when you're creating accessible content. So there was already a semi-introduction for me, but I wanted to let everyone know that I am a white male in my mid-40s, and I have a little bit of gray hair. I'm in my home office, but with a virtual background, and I'm wearing a gray shirt currently. I've been in the field for over 15 years, and I've really got the opportunity to work in a number of fields that includes the disability service offices, in assisted technology in K-12, and then now in digital accessibility, working directly with content. I am a certified professional in accessibility core competencies by the International Association of Accessible Professionals, IAAP. If you're not familiar with this organization, I strongly encourage you to look into IAAP. As was mentioned, I serve as the head for digital accessibility at UNC-Chapel Hill. And I'm also an individual with a learning disability that actually found out about my disability later in life, in college. And I've used a lot of the tools that we talk about here in this presentation to really make it so that I can comprehend and understand content. And so I do have that firsthand experience I'd like to share with y'all. So the first image, or the first thing I want to dive into, is an image of the 1900s. And so this is a black and white picture, maybe from the 20th century classroom, where students are writing on paper. Looks like there's a male teacher standing by the bulletin board. And so this is, I can't really tell what kind of activity they're doing. It could be math, it could be history, but they are, their face is sort of just stuck inside of their pencil and their paper and on their desk. And so it's a very static situation. There's not a lot of nothing really interactive going on. And it just seems like, you know, pencil and paper was the main communication medium at the time. And so this was your typical view of that environment at the time. Now let's look at a more updated image of a high quality image, that is, with color and you know, lots of exciting things to look at. This is an example of a typical science classroom in the year 2022. This classroom has a smart board, it's projecting data of charts, of different information. Students even have individual tablets and laptops at their desk. And so this subject here being taught with science seems like it, you know, it has a lot more than just the pencil and paper. It has your visual graphs. It has lots of large images that are shown up on the smart board. This is a very more interactive learning experience, it looks like. So why am I even showing you these images to start off with? Well, I really wanted to sort of highlight that classrooms have changed over the years. There's no doubt about that. But at the same time, though, have they changed so much in what's expected of the students? That's a yes, and it's a no. Let's dive into it. So students factor there's a lot of factors that influence where a student actually is going to pay attention, or if they're going to fall asleep, if they're going to retain information. And some of these things might be as simple as learning preferences. I mentioned having a learning disability, and my learning preference does play into how I learn a lot of times. There might be motor skills or mobility involved in it. Things like sensory function, whether someone can see or hear. Cognitive, how much can they understand what is going on intellectually? Literacy skills, do they have the understanding to be able to correct grammar and make the right sentence structure? Language and communication, can they be able to enunciate and elaborate and be able to get their point across by using their language? What social emotional impacts going on in our world actually influences our students and their motivation to learn? And then also the attention and organization that they have are all part of that. Some things that are not on the list that should be considered is what content the student needs. So for example, they might just need maybe it's numbers, and then you have some students that need pictures, other students need videos. So there might be documents that they might need, or there might be multimedia that they need. What tools do they have that's available to them? Maybe at home they're used to watching YouTube, but at their university there's a program called Panopto that does all the video hosting. And so also a factor that plays into it is how much money is being spent, whether it's the student's money or the university or institution's money that's being spent. That could be whether or not they're hiring certain faculty member or certain instructors that understand the content and can teach that content. So there are more factors, but these are some of the most common ones. Now, regardless of any of these factors, I always encourage folks to do universal design for learning. So if you're not familiar with UDL, which I hope most of you are, the North Carolina State researchers are really the founders of UDL teaching practices. And if you look at some of these practices, it goes into looking at ways for interaction, which is what I talked about in that 2000 or 2022 image. You're going to have multiple means of representation, not just sitting there on a text, pencil, and paper. You're going to have multiple means of action and expression. Maybe it's not just raising your hand, but maybe it's answering questions, or perhaps maybe making an exam that actually shows that they have the understanding of what the topic is through another way outside of just pencil and paper. And then multiple means of engagement. So the students are learning in different ways and have different motivations. These are the core concepts of UDL. And so as we talk about making STEMs accessible, I want you to keep that in mind as sort of the hallmark of why we do what we do to make things accessible. So what are some typical math tasks that are done by a STEM student, a student taking engineering, a student taking math? Some of these can include sorting shapes, analyzing patterns, estimating, measuring, looking at fractions and decimals, money and time. Maybe it's perhaps reading and analyzing word problems or step-by-step logic. Maybe it's reading a math textbook and worksheets, or using calculators, science calculators, scientific calculators, graphing calculators, lots of different ones out there. And then, of course, a big part is test taking. So we at UNC like to say accessibility is a process and not a project. So, excuse me, as we're talking about some of these best practices, one thing to keep in mind is that you're not going to be able to do it all overnight. You should really chunk it out and think about things that you really want to work on. Maybe prioritize things, set these goals and deadlines. Maybe it's not trying to do the entire content through a semester. Maybe it's make it happen through multiple semesters. You do want to try to design new content with accessibility in mind, and then think about auditing and fixing things based on how much their use is. The end goal is usability for all users, but at the same time, though, you're always going to have challenges for individuals that do learn differently. And so keeping that in mind, that you might think that you have something accessible, but there might be someone who's still facing a barrier, and keeping in mind and being open-minded to be able to make those changes for the individual. A lot of times people say, but it's on the computer screen. Does that mean it's accessible? Well, I wish that was the case. To make digital math so that it can be read aloud by screen readers and other AT or assistive technology is just one of the first steps in creating STEM materials. However, if you think about it, digital math is not necessarily accessible math. Now, I took this and adopted it from the North Carolina College, community college system, virtual lab community that I mentioned, their math guide. They said that accessible STEM is content that everyone can perceive, interact with, and explore. I love that definition because it's interact with. That's a lot of times what we're doing, and what you didn't see happening in the 1900s as much. And a lot of times the interaction involves making sure it can be found in different ways. And so one example is, can you interact with it? Well, you have the example of the Microsoft equation editor. That will actually make math, so it's digital, but the problem is it accessible? One of the ways that it makes math digital is it creates an image. That image still needs an alternative text tag, and that's still really just reading it. That doesn't mean you can highlight it. That doesn't mean that you can manipulate the information. And so having math that's on your computer screen does not necessarily make it accessible. It might make it digital, but doesn't make it interactive. People always ask, where do I go next? So I understand what you're saying, Brad. I want to do this. So where do I go? Well, the first thing to do is to think about the concept that there's a lot of variables in making STEM accessible. It's not just here you go this process and you go that one. There's several options that one must think about when creating STEM content to be accessible. One of them is the technologies that's needed. Another thing is you want this planning to happen before the workflow happens. So what we encourage individuals to do is think about how you're going to be creating your content throughout the semester. And don't just do this for this one math book. you want to think about how you're doing your workflow throughout. So if you're creating exams or if you're taking content and putting it on your LMS, you want to use the same tools and the same methods so that someone that's taking an exam, or I'm sorry, doing practice problems, can do the same type of interaction and work when it comes to doing things in the test environment as well. You want to remember that there's more than one way to get it done. And so a description that I might give you, for example, if I was hired by, let's say, NC State University, and they had a faculty member that needed to know how to go from the PDF all the way to a Braille format. Well, that might be very different at, for example, Duke University because of the tools that are available and the resources, the understanding. And so while I'm going to show you some considerations that you might think of in the different compartments of it, don't think that this is an example of how you do it from start to finish. Now, I give an overview here, and I mentioned this in the beginning. You want to actually have a starting format. So this is really what you have, whether that's a PDF or a Word document. You want to think about your assistive technology. You want to think about any math authoring tools you're going to be using, your desired format, and then also that delivery platform that you're going to be using. Now, obviously, I'm going to go into more examples into the future slides, but that's an overview of what we're going to be looking at today. So your starting format. We all know what we're talking about when I say starting format. That could be that math book that was provided in a digital format, or maybe it's not even a digital format, it's in a physical format and needs to be scanned. And the copier that does it creates it in a PDF. Well, there's going to be optical character recognition that needs to be part of this process. So think about if you have a PDF, a lot of times it's just really an image most times. And especially if it's made from a copier, such as a book, there's going to need to be technology called optical character recognition implemented in order for the computer to know what that text is on the screen. You might actually have an image of a math content, similar to what we were talking about in PDF, but maybe it's just a JPEG or a bitmap or a TIF. In those instances, that same technology I've talked about in optical character recognition, OCR, it needs to be implemented again. Or you might even have some advanced scientific language, LaTeX, also called latex. I pronounce it LaTeX. But this is a typesetting system that features a way to produce technical and scientific documentation in a way that's universal for everyone that's actually writing. It's almost like a different language that people are speaking in the scientific community that is the same. It's free to use and it's open source. There's also a link to the LaTeX community. So if you want to learn more about it, most of your faculty that deal with any type of math or engineering hopefully will understand and know LaTeX, and this will be a great starting format for them. Also, you want to consider the assisted technology or accessible technology that's used by your students. And this is not going to be the same for everyone. And so what I did here is provided just an example of the most popular assisted technologies that are out there. The screen reader, you've heard a lot of individuals mention, usually used by blind or low vision individuals. Some of the more popular ones are JAWS, NVDA, or VoiceOver. This is a really technology that reads the entire screen. Very different from a text-to-speech software we'll talk about in just a second. It reads the menus, the commands, the entire part of the screen without any interaction through a mouse. And usually individuals use a keyboard only. Text-to-speech, such as read and write or Kurzweil, is more of a select what you want to hear type of accessible technology. And it allows for individuals with learning disabilities, for example, to be able to have a floating toolbar that they can then highlight what they want and then hit a play button on top of that content. So it interacts with that content, whether it's a PDF or Microsoft Word or a website, well enough for it to be read aloud. You might have someone using a speech to text or speech recognition. Siri, Google Assistant, Dragon, Naturally Speaking are some of the more common ones that are out there. I mean, that's really what it sounds like. You're taking your speech and it's outputting in the text. This technology has come a long way these days. I know, for example, Zoom has the live captioning, which does a lot better job than even YouTube of live captioning, better job than it did just 5 to 6 years ago. You also have magnification software such as Zoom Text or your built-in Zoom features inside your operating systems. And then you might have an accessible technology such as a desktop video magnifier or CCTV that an individual with low vision might be using. So right now, you know your starting format, you know the technology, or at least you're aware of the technology. Now you need to consider your math authoring tool, or it could be your STEM authoring tool. And the most common ones out there is MathType. And this has an application with an equation editor. It's got plugins that go in with Word. So it has a lot of different integrations that work very closely with a lot of what academia is using today. It also works on multiple platforms. So whether or not you're on a Mac or a PC, MathType is going to work in there. So a lot of our math faculty, they use that. You might be using a tool called Equatio to author content. This application is one of the newer math authoring tools out there because it actually allows for you to use different inputs. So for example, I don't think MathType has this feature yet, but you can actually speak the equation, or you can say quadratic formula, and it will throw in the quadratic formula into the digital math you're trying to create, and it will be accessible. You can also use handwriting or screenshot capture with this program. There's also MathPix, which is an application that converts those images we talked about earlier that were just images into PDFs in different accessible formats so that they have optical character recognition already done for them. There's Infinity Reader, Kim for Word, and Dismo Graphics. I'm also not gonna have time to go into more examples of those, but those are other authoring tools that are out there. Maybe your faculty member has their own favorite one. It's going to be good to check with those instructors and find out what they're comfortable with using. Because what we always tell folks is that we don't want you to start using a tool to tell you to make content accessible, and you have to spend more time learning that tool. It's best to find out what you're using and find out what ways it can output things, and then get it into the formats we want. So even though I didn't mention maybe the tool that you use here today, there still might be possible to still use it. The last thing the next last thing you want to think about is your considered desired format. And most times it's MathML, or mathematical markup language. What this is it's a language embedded in XHMTL. And what it does, it allows for it to actually be read aloud by different technologies, such as screen readers. And it will make it so that it's displayed. If you look at the third bullet point, it shows an example, x2 plus 4x plus 4 equals 0. Well, the markup language for that, which is not anyone's probably going to write down, it's probably going to be outputted from one of the authoring tools, is it's going to come out with this very long, looks like HTML format that's going to be outputted. So this is going to be the most popular and most accessible format that's out there. You also might have situations where you need a scalable vector graphic, an SVG. And what an SVG is, it's taking a two-dimensional graphic and actually giving it certain properties. You heard earlier the discussion of ARIA. And so taking some of the concepts of that and building it into really a graphic that can be scalable with embedded information. So not just your typical, this is an image. It's going to actually have information that could be time-based, it could be keyboard accessible, and all that content can actually be navigated usually through your keyboard and be very interactive. If you look up chemical, and you can even go to Kim for Word. If you go to any of the type in SVG and look at an example of that, it's amazing what you're able to do with taking a simple, such as a chemical formula, and being able to make it so it looks like an image. But because it's an SVG, you can navigate it to make it so that it twists and turns. It has color change for carbons. So definitely, if you need SVG, that is a desired format. Or a lot of times for your chemistries and biologies, SVGs is a desired format that's not thought of as math in itself, but still considered one of the STEMs. You're also going to have the format of Braille Ready format, or BRF. What this is taking that content that you created in a format and being able to output it onto a Braille reader. So such as whether it's a refreshable Braille device, or it's actually using a Duxbury Braille translator to be able to use a Braille embosser, also called a printer, a Braille printer, that will actually print it out for the student so that it's now in Braille format. So that could be a desired format as well. There's also the platform delivery is considered. So where is this going to be hosted? Is it going to be in your LMS? Is it going to, many times that's where it's going to happen at. And so web with MathJax, which reads MathML natively using JavaScript display engine, will actually make it so that you'll put in the MathML and it will output onto your computer screen that accessible math that can now be used in your LMS. And so that is one thing to consider. You might also have e-publications from your publishers, whether it's Pearson. Vital Source is very common. Pearson puts a lot of their titles, so does McGraw-Hill, or a EPUB readers, EPUB platforms such as Redshift. They also have a lot of content that is accessible STEM content that's available in their systems. You might have the output, as I mentioned just a second ago, an embossable Braille, refreshable Braille display. This isn't really a platform per se that you would make, but I do want everyone to look at the PET Interactive Simulations project. This is really an interactive research-based science and math simulation group out of the University of Colorado Boulder. And they have created a lot of simulations that are completely accessible. You just do a filter for accessibility, and it will pull up things like the chemical display of sugar. And so it'll show a simulation of sugar and what the chemical formula looks like with one of those SVGs we talked about. So if you do get a chance, look at PHET Interactive Simulations, because they have a lot of wonderful content that's there. The next the example I want to show you is here is a table that actually shows a math type object that was converted from LaTeX into math type using LaTeX into math type, where it looks like the quadratic formula, and then it shows exactly what it would sound like inside of math speak using MathML that it outputted from math type. So just to make sure you understand, it was in LaTeX before. From LaTeX, it got inputted into math type. Math type spit out in MathML, and then they were using a text-to-speech software called MathSpeak that will then speak it aloud, just how JAWS or a screen reader would as well. And you can look how probably very hard to understand what the LaTeX or tech as it's shortened here, how it looks very different from the actual visual quadratic formula that visual people come and know versus what it actually reads out. And then down below, there's also an image of a Braille ready format version of what it would look like in Braille as well. So here's an example of sort of start to finish, so that, you know, as a instructor, you can see all the considerations that you're going to need to do before you actually design it, before you create a process to take all your STEM content and make it accessible. I put in a number of STEM tools and resources here. So you have the what is mathematical, what is MathML, you have contents for SVG accessibility support. I mentioned the LaTeX project. There's also content for WCAG quick references, STEM resources from Do It, from the University of Washington, as well as a brought-in participation in science and engineering by Welcome Participants with Disabilities. It's a wonderful article that's there. There's also links to, I mentioned, to our accessible technology vendors. I mentioned most of these when I was going over the slide. And then there's some STEM tools resource links. I definitely want to highlight the one that I have starred, which is the North Carolina Community College Systems VLC, Virtual Learning Communities Math Guide. This is a really wonderful free guide that was created by the folks there that they've shared with our organization, the North Carolina Higher Education Digital Accessibility Collaborative. And I really think it takes what the content I've taught you today and really makes it so that you can actually see it in person and take some of the suggestions that they have there. So this is the time where I have questions.
Okay, so we do have a few for you, in addition to several thank yous for all of this great information. Let me get my list pulled over here. Okay, so the first question is, what thoughts or advice do you have for transforming handwritten math from scanned documents? You mentioned a couple of resources, but do you have like a favorite strategy?
Yeah, I would have to say my favorite strategy is using a program called Equatio. And so Equatio, you have a lot of faculty member that will do their slides or even their work, and they'll instruct the students to take a picture of it. And so what Equatio does is it takes handwritten documents, allows for you to number of ways. You can actually hand put it through a tablet device and allow for it to recognize the handwriting that way. Usually it does it through the math editor that's inside of Microsoft Word. So you can input through just a pen, the digital pen, or what it will do is it'll actually take your handwritten content and allow for you to snap a picture of it and then import that in there and then allow for it to do its magic behind the scenes. It actually uses optical character recognition to find out what the handwriting is. Now it allows for you to check it because it like an automated system that doesn't always get it right, but it will allow for you to be able to check and make sure it looks right. I've had a lot of success with it, and I'm not sure if you have as well. So.
Yeah, I do. We're big Equatio fans here. But I'll put in a tiny plug for Infantry Reader because occasionally it just gets a little bit cumbersome to like have to scan each equation using Equatio because it's really focused on recognizing the math and not the text. Whereas Infantry Reader is geared more towards scanning a whole page so that you get both the text and then the equations are their own objects. So they both have their benefits depending on what your end goal is. And this question is related, so I'm going to jump in the order of the questions here. So the attendee asks, do you wait for the accommodation request to make the accessible content? Or are you working proactively to support STEM content beforehand? And I think a key part of this is if you choose to be proactive and you don't have a specific student in mind, where's a good starting point?
Good question. And I think for many of us, it is actually getting it in a digital format that's copy and paste ready. And I think that's going to get probably the usability and accessibility for a large population. A lot of times when you get those disability requests and it's for a blind individual that uses a screen reader, those don't come that often. I'm not saying they won't come, and you probably should be ready for them eventually. But if you had to get a suggestion on what content to prioritize, it would be the content that is digital, that you want to make it so it has optical character recognition. Because once it's OCR'd and the computer knows what numbers are represented visually or there digitally, then you can use one of these systems like we just talked about, like Affinity Reader or Equatio, to be able to put it into multiple formats. And a lot of times what will happen if you're using an older textbook or if you're using content that's that hasn't been digitalized yet, even though we went through a huge pandemic and everything, you should have already done that. But if you do have content that's still in paper format, then you can scan it in using multiple, whether it's your phone camera or a copier, and then use optical character recognition to get there. And like I said, that'll be a great starting point if you want to prioritize that. And then from there, like I said, you can take those other steps towards using it with Equatio or math type to be able to output it in other formats to make it more accessible.
Okay, so it sounds like you're saying thinking about things like the pages on your learning management system or the homework assignments, the things that you use all the time. Yeah. Okay. Let me make sure I get the whole question. Okay. So this one's related. I think we've heard this question once already today. How do you support departments when they say they'll never have a student with this need?
Yeah, I actually, I'm not laughing at it. I'm more grinning at because I've heard that question. And I'm sorry, I've heard that statement. And then a semester later, a deafblind student actually enrolls into the school and is actually majoring in engineering. And so it's one of those situations where it goes a lot of what Crystal was talking about. I also heard our other presenters mentioning it, is that you have to chip away at it, saying you need to be inclusive, and not to mention you need to bring it into a way that we're in a digital world now. And so we're no longer we might have another pandemic and we might need to transfer all the content that we're used to having in a physical format and make it more digital. And so in those instances, even though you may not have someone that needs an actual accommodation, you still want to make it more usable. And then when you're making it more usable, you might as well make it more accessible, because that way, if you're already taking the steps to make it usable, you can make it more accessible.
Definitely. Okay, so let me jump this way and I'll come back to these ones. Can you share any tips on determining how accessible the math is if you're using an external resource, like something that you were provided by a peer or something that you got from a publisher? What are some strategies there?
So first I would test it. So Crystal did a wonderful job of suggesting a number of testing tools. And so those are testing tools a lot of times for web. That doesn't mean it can't be taken and used for some of the content we talked about. Perfect examples, we looked at scalable vector graphics, SVGs. Now they're probably going to have an SVG on the file type ending as opposed to a JPEG. But if a publisher provides something that says SVG, then all you got to do is use a keyboard to start tabbing through it to make sure it goes through the progressions of what's the content inside that graphic. And that's how you know it works. That's one example of using that. Maybe it's digital content that's from a publisher that's math. Well, there are a number of free screen reader softwares out there. I use NVDA almost daily because of the work that I do, but you can use one of those screen reader use platforms, or even one built in if you're a Mac user, VoiceOver, for example. Fire it up and actually have it read aloud. Now, when you say fire it up, it's probably not as easy because I'm in the business. So it's like telling an instructor to fire up a screen reader is probably the wrong thing to do. But at the exact same time,
I've tried that.
It is possible to actually take a screen reader and learn the most basic common commands towards reading and progression using a free one like NVDA. Most of the time, your disability service office, or if you have a digital accessibility office, will have keyboard shortcuts that they can share with you. So when they say fire up a screen reader, it won't be as difficult as opposed it's more than just installing the .exe or the Mac format. So that is one way that you can actually test it to make sure that it is accessible, and then also just be able to see if you can copy and paste it. If you can't actually highlight it yourself and copy and paste it, then 9 times out of 10, it's not digital. And that happens with text, not just with math formulas or anything in particular.
Yeah, I'm a big fan of the highlight test. And in case that wasn't clear earlier, when you use the screen reader, you as a sighted individual can still use the mouse to position the cursor in front of the math and see how it reads.
Yeah.
Okay.
Yeah, it's almost like cheating, because as a visual user, you can't actually place it there, whereas someone that's more proficient with a screen reader will know how to navigate to the content itself. But you can sort of fire it up and cheat, put your cursor there, your mouse cursor there, and then start reading it.
Awesome. Okay, so let's jump over to this question. Allison would like to know if we can hear a couple of real world scenarios in which you needed STEM content to be more accessible than you want, or than it was. Scenarios with either the professor or the student having a disability.
Yeah, so the latest example I can, there was a lot of work for everyone involved, was an individual that was deafblind. And so the individual had to take content that was from pencil and paper. And the instructor had to actually, whether it was the PowerPoint slides that the professor still gave as a printout, they refused because of instructor rights, would not give out the digital copy of it. We had to, as an office, work together to get that professor to give the digital copies of it. But if they give digital copies of it, then at that time to give the copies that the student could then have be made accessible, and they use a refreshable braille. So in this instances, The student did not, they could have, they had some hearing, so they could hear JAWS. They could hear the screen reader talking to an extent, but it wasn't their preferred method because of their hearing impairment. They preferred reading Braille with their fingers. And so they had to refresh a Braille device. So that was a real world scenario where we took with a paper format and actually had to work with the faculty member and show them instructions on take these techniques that we're going to teach you on how to do that. So this student that's in your class right now will be able to take the exam come 2 months from now. Now, we knew about the student coming into the course a couple of months before. So we were working with the student and the instructor during the summertime. So it was ready by time, or at least the first 3 weeks were ready in the fall. They were still working. The actual department had hired a teaching assistant to help the instructor be able to do this process. So that was a scenario where it was a real world. This wasn't a proactive, this was a retroactive situation. And so that's one of the best examples I can give. The professor actually, he's at the University of Central Florida. We still stay in touch because there's things I told him that even though he was resistant at first and didn't really like technology, he sees the benefit from it from all students. And so we still stay in touch. It was a fight at first, but it was one of those where, in the end, the instructor knew that this student could not go through UNC's engineering program unless his class was accessible, and knew he was the one that caused the barrier, not the student.
That's a good story. So kind of a follow-up to this piece of it is, would you say that for those people who want to try to do this proactively, is the priority more cognitive disabilities or other kinds of invisible disabilities? Or are we making assumptions about it being related to people using assistive technology?
That's a good question. So I think when we look at the content that we have, and I'll use captions as an example, there are a lot of folks that use what we can call accessible technology every day that don't even know they're using it, whether it's Siri, which was originally created for folks that needed to be able, they didn't have use of their hands and they needed to speak with the computer. We use that technology every day, whether it's to ask for, trips to Starbucks, or, whether it's to find, where the dentist office is, which I did this morning. It's a case where we're doing that, using that technology, that assistive, accessible technology all the time, and not even knowing we're doing it. And so how I answer that question is there's a lot of the technology that only used to be used for individuals with disabilities is being used by everyone these days. And so for that reason, we need to sort of try to keep up, with students that are using their computers. I mean, I know a number of students that are actually, they use their phone more than they actually fire up their laptop, just because they're more comfortable with their, it's a 7-inch screen. And so they expect their LMS content to be accessible inside their screen. And a lot of their technologies, because it's an Apple, it actually already has voiceover and all the tools that they need in order to make it work. So,
yeah, I like that. All right, so for those text-to-speech programs that read aloud, are any of them, oh, sorry, my apologies, it's the speech-to-text, so speaking it, having it interpreted. Are any of them better at interpreting different accents than others that you know of?
I love this question because it's one of those where we found out that I'm not gonna lie, I have a drawl. Y'all can hear from me speaking. I have a little bit of a country drawl, slang, Southern drawl to me. But I think if you train some of these speech, if you're a user of speech to text and use it all the time and have the opportunity to train it, such as a tool like Dragon or the built-in OSs, it's gonna start to learn the way you speak a lot better than if you were to just look for directions. Because what you have to think about it, when I'm looking for directions and I'm spitting out something in my phone, even if it's a text message to a friend, that's a short snippet. It's going to use a supercomputer up in the cloud to be able to figure out that little snippet. But if you're using a speech to text program, you're going to want to actually have it learn your speech for you. And so, yes, the answer is there are ones like Dragon Naturally Speaking does do a wonderful job of allowing you to train your voice. Dragon was bought by Microsoft. I don't know if anyone knows about that, $17 billion. So I don't know how long Dragon Naturally Speaking will stay alive if Microsoft plans to incorporate it into what they do. But at the same time, though, I've had a lot of students that have dexterity issues that did not know how to use a computer outside of only Dragon. And so they had voice files that they constantly trained it, and it did a really wonderful job of understanding even when they had a cold, because it was something different that the speech to text wasn't used to hearing. So they had to train it. I tell the story all the time that back when I first started, I was working in an AT lab, and the student actually that had a cold. It wasn't working for the student, even though they had been using it for 4 years and had the voice file loaded. We figured out the reason it wasn't working very well was because her cold was so nauseated, and so her voice actually sounded different. And so we actually tested it, and actually she's like, well, it wasn't working the last time I was sick too. And I'm like, that's actually the reason why. and so
figured it out.
So yeah, these speech to text are a little bit particular on that.
Nice. All right. So our next question is going back to the handwriting here. It says, one issue that I had during the pandemic was writing math or physics equations on the fly. I was able to do this using a stylus, but of course, not all the students have a stylus. So what are some good practices to make that classroom environment equitable and inclusive?
It's a good question. And so if you're using a stylus, a lot of times, like that program I called Equatio, but also Microsoft has the stylus, has the handwriting editor inside of a Windows computer, and it does a really good job of recognizing that text. And so once it's actually taken from your handwriting into one of these applications, whether it's the full-blown Equatio program we talked about, or just into Microsoft Word using the handwriting style editor, that's going to make it so it outputs. So like if you draw a 5 + 7 = 12, it's just an easy formula.
Right.
It's actually going to output that into a text.
Okay. Yeah, that is a nice idea. I think even the Equatio has a piece of their product called, isn't it called Math Space, where you can essentially do that on the fly, or you can pre-program it where you do the stylus and it produces the digitized math.
Correct. It uses actually Google Docs is what it's with the space it likes to be in, because it started off as a Google product. But yes, you're correct. It does do that space automatically.
Okay. The next question here, this is a good one. This speaks to the accommodations piece when it's not proactive, but it's intentionally reactive. Gretchen asks, how do you recommend instructors coordinate between semesters? For example, a student will move from engineering 150 this semester to another engineering course next semester.
The first thing I suggest to do is to look at your course a little differently. And so you have to think about, you're going to have to look at the content you're going to be presenting. And maybe, for example, you might have given 30 pages of homework. Maybe you think about, is 30 pages something that is going to be manageable for this content? And so not that I'm suggesting you do anything differently, but just think about, was it 30 pages made sense, or was it just something they could practice doing it? Maybe consider, do you have 12 pages of examples in your PowerPoint slides? Maybe you just jot it down to maybe 2 or 3. So think about the content and how much of the content you have. The next thing after you look at your content is then prioritize the first 3 to 4 weeks. So you have to think about, you're probably not to, even over the summer or even over that break, you have a life. So you're gonna have to still think about timing of how you produce stuff. And usually what the best practice is to take that first 3 or 4 weeks and concentrate on that. And that way, during those 3 or 4 weeks, you're working on weeks 4 through 8. And so you just stay ahead of the game that way. Obviously, there will be roadblocks, and you're going to have to probably ask for help. So don't be scared to ask your department head to go, it's just way too much. And there is a student coming, so please help me, whether it's hiring a teaching assistant that can assist with this, and I'll still allow for you to A, do research, or B, teach the rest of your classes or grade the rest of the work you need to be doing. So don't be afraid to ask for help. And you might have a disability service office or even a digital accessibility office that's providing the services of assistance. And then there's third party. When it all comes down to it, there are a number of services out there that will charge you to make content accessible, whether it's your PDFs accessible or even if it's STEM content. STEM content costs a lot. So for just an example, we had to do a Braille book at the University of Georgia, and the student, I'm sorry, a large print book, the large print book. It was back when more of the content was available, less on PDF and less digital. And so they did the book. It was $40,000 to make it large print. And the book was actually done in volumes because the large print made the paper so thick, because it was an 11 by 14 glossy paper. It made it so thick, they had to do it in volumes because the student could not carry the entire book like they would a regular sized book. So there are services, and definitely you can reach out to me. I can give you a number of those services that are out there that can produce that content, but don't be scared to ask for help, because it's once you have it, assuming you don't change your content up too much, it'll be usable in the future. And so it might be worth investing both the time or even the resources to make it so you have it. So there might be a student in the future that needs the content accessible as well.
Okay. I think one other piece of this question is, when you do pass the student off from your class to the next professor's class, are there things that people should proactively be sharing?
Oh, yes. Yes. In fact, I can share with the School of Public Health here at our university, set up a Teams page. And the Teams page was to support the student. But a big part of that is to actually, because the students in a graduate program will be going and using similar professors, but be in different classes. It was a space that they could allow to share resources, and they shared practices that work to support the student. I thought that was a genius idea, because we all have, most of us have Microsoft Teams. And so it was actually under her initials that was, for there, and because she was a deafblind student. And so the School of Public Health is able to actually share resources as the student passes along through her curriculum.
Awesome. That is a good tip. So speaking of health sciences, are there any libraries or repositories of science-related graphics that have good alternative text? Like a place where you can go download that image, or where it has the image and a copy of the alternative text, things like muscle groups, parts of the brain.
I mentioned that PET simulation site. That does a really good job of a lot of content, but off the top of my head, I can't think of any. Do you know?
There is one by Benetech.
Diagram Center.
I'm trying to, from the Diagram Center. I'm trying to think about where it is, because Charles LaPierre likes to talk about it, and I have borrowed stuff from there before. Maybe if one of us can find the link for it.
I know exactly what you're talking about, because I've heard it in the EPUB work groups that were part of.
Maybe we can add that to the resource links at the end of your slides. We'll track it down and add it. Okay, I think Sarah has just found, well, she found the description guidelines, but there's a link to an actual repository, which I think they might still be beta testing. So we will track down that additional, but this resource that Sarah posted is definitely a great one. Okay, we've got time, I think, for one more question before we wrap up. And now my question cheat sheet has moved. Okay, here it is. Okay, what about math equations that are part of an image? What strategies can you share for ensuring that the equations within the image are also accessible?
It's a good question. That's a lot of what most faculty members are going to encounter, is they're going to come across in a textbook. And a lot of the textbook, let's just say a physics book, physics is going to have a lot of text in it, and all along here comes an image that's actually a equation formula. And so you're going to want to actually use optical character recognition. We talked about a number of different tools that will then take that equation and be able to spit it out into another format. And at that point, we could then use one of the authoring tools to make it more accessible. So that's going to be the best way to do that. Is you're going to you could use Affinity Reader that you mentioned earlier, but there's only a little bit of equation there. So that might be a place where you use a screenshot checker like an Equatio that will highlight it and use auto character recognition for it.
Yeah, that's definitely my favorite way to do it is with Equatio, because I know it's been vetted. The way the math has been read out loud has been vetted by a group of experts. So that's definitely my favorite way to do it. Okay, well, I think it's my time to pass it off to whoever's going to do our closing. So let's give a big virtual round of applause here for Brad. Thank you very much.
Appreciate it. Thank you so much.